In this video, we're going to look more at the Unity engine, and I'm going to start up by showing a demo project that it's not a complete game, but it has many components, nearly a complete game. So taking a look at the scene view, we've got a 3D text showing some of the topics we're going to take a look at. First, we'll just give the game a play and talk about some of the screen components that we see, and then we're going to look at the code for the Gui text, the sound, and then doing input with both mouse and key. Then we'll take a look at how to set up that second camera that you see in the upper right of the game view, and also talk a bit about prefabs. The last section I've included, if you open up the source code, which is available on the same link as this video, you can take this project and add more to it. So those are some of the ideas of how you could take the loose code base that's here and turn it into a complete game, or add to it if you want to experiment a bit with what we've got here. So first we'll just give it a start. Notice I have maximize on play clicked here, so that means that each time I enter into play mode, it's going to show that window large for us. And then when we end play mode, coming back into edit mode, it reduces the window size, so it saves you from having to do manual resizing. In certain games that matters more than others. Certain projects you want to see how the layout happens and how things resize to different size screens. Also, we can see in this free aspect window, we can lock that down to certain aspect ratios. So currently it's in free aspect, meaning that if I resize the game window, it's going to fill with the game world rendering. If I lock it to one of these other choices, we'll see some letterbox bars either appear in the top or the sides, depending on which format you want. So 16 by 10 is the newer iOS devices have that. You might want to test out how your layout works in a variety. But since we're not developing for a specific device yet, we'll just keep it on free aspect, and then you can see that if I resize, we're always getting the 3D world rendered end to end there. Also, you can see the stats button, which will show some information about the rendering. So as you get closer to the end of your learning of Unity and you start thinking about how to optimize for your target platforms, you may want to get some of the basic nuts and bolts of your game rendering out onto the screen, if it's 2D or 3D. And be checking out the statistics that are generated here, and there's quite a bit written online about what devices can handle as far as the number of vertices that you're rendering and the draw cost in the case of 2D. That's outside the scope of this video. And then the gizmos. The gizmos are meant to be any of the GUI elements that are only for editing. So while we're here in edit mode, you can see that there's a speaker placed on top of each of these pins. If I change it to 2D, they appear smaller, meaning that regardless, let's look in the scene view, regardless of how I zoom in and out, those different icons that are in white stay the same size. If, on the other hand, I change to 3D gizmos, then as I get closer to, let's say, the pins, those speaker icons get bigger. So gizmos can indicate a variety of things. Here they're indicating certain components that are on game objects, namely the sound that is on some of the game objects. Up here there's what looks like a sun with light rays, and those are the directional lights that are in the scene. So I'll turn the gizmos back to 2D. That just tends to make them a little bit smaller and less invasive as we're looking around. So I'll keep that list of text on the left, and then we'll just go ahead and play. So what I've done here, again, it's not a complete game, but it's pretty close. And what we've got, let me turn gizmos off, yeah. So what we've got is two camera views. The one camera that's filling most of the world stares down a bowling lane with 10 pins. And then using the mouse, we're able to choose where we want the ball to start from. And then by mouse pressing, it rolls down the lane and then collides with the pins with real physics. Then we've got some sounds happening as well, which we'll talk about when we code the sounds. And then in the second camera, we're looking at the same 3D world with a different camera that's placed above the pins. And I'll talk about how you render that just into a small square In your game, you may want to do that as an overhead map to the world, or there's a lot of different ways you could do it, but a map or an overhead view like that what we have here, kind of picture-in-picture, is very common. Then by pressing the mouse button anywhere, it just restarts the whole scene. So there's no score being kept, but in the left you can see the pins hit at 0 of 10, and then after I bowl, it does some calculations and says, okay, we've hit 6 out of 10 down, and there's still 4 standing up. So there's a section in there I want to look at real quick that just shows, how do I decide once you've hit something. There's a couple ways you could handle that, probably even handle it better than the way I did, but all I'm doing is asking if it's in its original rotation, rotating up, and compare that. So jumping back into the game, let's just step through these. So first, looking at Gui Text, because I haven't explored that in an earlier video. We'll go into the scripts folder that's spoken about. And in here we've got components that are named based on what they're attached to. So most are attached to the bowling ball. So you could either find them by coming into the scripts folder here, or within the scene view, you can click on the bowling ball itself, or in the hierarchy view, you can find the bowling ball prefab and click on that. And in the case of clicking in the hierarchy, on the right now we see the inspector updates to show all of the components which are on the ball. And the ones that I've created custom are the 5 here: bowling ball, prefab, and then a little bit more info. So we've got one specific to the audio, one about the keyboard input, one about mouse input, one about the score, one about the general game state. So this is attached to the ball, but in a larger game you might put this type of logic somewhere independent, maybe on an empty game object off to the side, and that's generally called a manager game object, an empty game object that's in the 3D world with no graphics, and you just put code that is best speaking about the entire game experience rather than dragging that onto something unrelated such as the ball or the pin or the floor. But here I've got it attached to the ball. And then there's a bit on the bowling pin itself just to play the audio. So let's take a look at each of these in turn. So the score component, I'm going to open that, and it's going to open up on a develop. All right. So here we extend from mono behavior, and I'm going to double click the tab here to make this a little larger. And what we do in the start, we've seen some of this set up in earlier videos. We're going to get a reference to the bowling ball state that tells us if we're in aim mode, where we're deciding where to throw from, or if the ball's already been thrown and we're in moving mode or something similar to that. Then I get a reference to the game object, only to quickly get its Gui text component. That's actually where we're going to do the updating of the text. So then every frame here in update, I'm setting the Gui text, the score Gui text components text property. And once we have this written out, we're able to explore its properties just by using the IntelliSense here. So you can see there's a variety of things that we're able to call. Some of them are specific to text. But just by setting its text property, we're able to say pins hit, colon, and then I've got a separate method for the number of pins we've hit and also the instructions, because the instructions are updated. So let's take a look at that. So pins hit 0 of 10, and then a line break, and then instructions. So the instruction shows the 2 steps here about aiming and throwing. Now once I release the ball, you'll see that the instructions changes to step 3, which just says to press the mouse button if we want to restart. So I press the mouse button, it restarts. So I've chosen to break it up into separate methods, but you certainly don't need to do that. You could do all of the logic all within that one highlighted line or in that same area. But what I'm doing in each case is I'm just checking the bowling state, and resetting it in the case if we're in aim mode, so that we see that we've knocked down 0 each time. We're restarting the small game here. And then I loop through and I check if the angle of the rotation of each bowling pin is straight up, basically. And if it's straight up, then I count it as not knocked over. And if it is knocked over, then I count up total pins knocked over. So that shows 0 of 10 in the beginning, and then eventually 10 of 10 if you knock them all down. So let me go ahead and just try and knock them all down. Let's see, it might take me a few tries. There we go. And you may notice as you're playing this that some of the numbers here where it says 10/10, that might jitter a bit or go like 9-10, 8-10, 9-10, 8-10. And that's as the pin is falling, it may be recalculating. Also, the logic that I'm using there is not the best. There's other things I could check instead, but the rotation was a dead easy way to start, so works pretty well for our needs. So we've seen mention of the game state component, the bowling ball state component, so let's take a look at that. So here I'm using an enum, which we've explored in a different video earlier. Enums allow you to set finite values within a possible set of values. So I want bowling state to be exactly one of these values at any time. It's either in pre-game aim mode or in moving game mode. And so then also the input mode, I just say, was the last thing that we've heard from, was that the mouse or did the user click the keyboard? I see a spelling mistake here, so let me just change that. Keyboard. And we'll update that. And I'm showing that you're able to capture both mouse and keyboard at the same time. Your game might also have a menu where you choose, do I want mouse mode from here on? And that's some flag that you set and use. But here I'm enabling you to wiggle the mouse a bit, then use the arrow keys, then wiggle the mouse a bit again. And so I just toggle into those two modes so that I'm able to keep track of what's important there. So I think by renaming that, I just caused an issue. But okay, we're back. So I renamed keyboard only. Now, back to the state component. So here in the state component, what I do is, in the update, update is run every frame. So that's 30 times a second in the case of 30 FPS, or 60 in the case of going something faster. But very quickly, this is regularly called. And I just see that was the arrow keys or the space last hit. If so, I change to keyboard only mode. And then if the mouse X or Y was hit, or the mouse button, then I change to mouse only mode. So the idea is at the end of every update, we have a value of either keyboard only mode or mouse only mode. And then that's used in another location. Then I expose a few public methods that will call from the input components. And one of the public methods is to throw the ball, and one of them is to move the ball during aim mode to a certain new spot. And another one is to move the ball by a certain amount. So in the case of mouse mode, I know exactly where I want to move it to. And in the case of keyboard mode, I know that tapping the right key needs to move the ball to the right so many pixels. So I expose two slightly different ways to move the ball. And then there's a reset game. So I simply reload the one and only scene that we've got here to redo a reset. But as I note in the comment there, you might have something more complex that you need to do in a richer game project. But for now, this works great. And probably for any prototypes and demo projects you do, that's a great way to get started. All right, so looking back at the list here, let's see how we capture that mouse input. So I'll give it a play, maybe each time we explore a new script, just so we can see again. So this is using that move mouse, move ball to type method. So that's why the ball is following my mouse. And then when I click the mouse, it does throw. So let's see how that works. Inside mouse input component, I check to see if we're in mouse only mode, so that this mouse component is only running when the input is mouse only. That's so that I don't cause too much collision between am I in mouse mode or not. There's other ways you could approach that, but this works great for now. Then I check to see if we're in that pre-game mode, because you should have control to move the position of the ball only during the pre-game mode. And then what I'm doing here is I'm using, see if I can shrink down the size a little bit. Here we go. In this first chunk, I'm casting a ray, which is a 3D line from the screen. If you could imagine, like from your eye through the screen, casting a line and continuing into the 3D world. I want a line like that to come where your mouse cursor is, so I can move a 3D object which is in the 3D world to follow along with the mouse. And coming from a 2D game development background, that might seem like a no-brainer, but in the 3D world you have the additional dimension of the depth to worry about and to coordinate exactly where the graphics need to line up there. So what I'm doing is I'm casting a line out, and there's probably other solutions that you could use here, but what I've done is I've put an invisible square, and that square or cube is going to receive this ray, and if it does so, then I move the ball properly. And if I didn't do this, if I didn't check, let me expose where that is. Under mouse detection, I've got a box, so you can see the green box in the left scene. If I didn't do that, then you would be able to bring your mouse up to where the word bowling is and up to the second camera, and that's not actually what you'd want in the game. You can see that as the mouse moves, you can see the cursor and the ball follows me, but if I go too far to the right or if I go too high, it doesn't actually follow me off the screen. The ball doesn't follow me through the floor. Right? So there's different ways you could do that detection, but what I thought to do is I just put this invisible box there, and then I just ask, is the ray coming through the screen and touching that invisible box? And then I manually, through trial and error, resized that box until it felt like it was the right screen positions for me. And it seems to work great. So if that position hits that invisible detection cube layer, then I go ahead and move the ball to where the collision is. Then to handle the throw, if you click the mouse button at any point, it does the throw ball. And then once we are not in the pre-game mode, which means the ball is rolling down here, in line 105 I handle the resetting of the game. And that's it. That's how we handle the mouse mode. Now let's look at the key input, and we'll see a parallel to that same setup. I don't need that invisible detection scheme anymore. Here I'm just asking if we're in keyboard mode in line 77, then if we're in the pre-game in 79, that puts us in here. We know that we're in mouse mode and in the right spot. And then I'm using the input class as existing methods. This is part of the Unity engine's robust way that you can accept input. So I'm showing keys and mouse, but there's lots of other options that you can have through there, including joystick support, for example. And then as well, you could connect through third-party APIs to things like the Microsoft Kinect, which can pick up your arm gestures and things like that. Or Leap Motion has a something like a mouse, but your hand moves through the air, kind of like a Kinect. So there's other options, but the built-in ones that are most common for prototyping are just mouse and keyboard, or maybe adding the joystick, but I don't do the joystick in this demo. So same thing, I'm just doing move ball by, and then I'm moving it over by a certain amount of units. When you click the spacebar, that does the throw. And then when the ball is rolling, if I click spacebar again, we'll reset. So let's operate with the keys here. Go ahead and play. And I'm hitting left, 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 right, 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 up, 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 down, 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 and then I'll hit spacebar to throw. And then at any time I want, spacebar again, brings it back. Spacebar again. I can also wiggle with the mouse, right, 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 wiggle with the mouse, left, 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 And it's gracefully toggling back and forth there, so you're able to choose at any time between the controls. So let's see how the move ball by, throw ball, and reset game all work. So we'll jump back into the prefab state. So in the case of move ball 2, I'm setting the transform position. Remember, this component is on the bowling ball, so the transform property is speaking about the bowling ball itself. So it's updating the position to a new vector, and I'm using the existing transform position z, so the depth never changes because I'm setting the current transform position to the current transform position z, so that's just reinitializing the position to the same z value. What's updating is I'm passing in a new x and y, and those x and y are coordinated from the mouse, so the mouse position is passed in. Move by, very similar. I'm just adding the incoming vector so that when I tap right, it can move to the right however many units it needs to move. Left, it moves negative, etc. We already talked about reset game. So let's look at when you throw the ball. So when you click to throw the ball, this is where I do toggle the mode so that all these scripts know that we're now in the moving mode, and updates the GUI, and that prepares the mouse input and keyboard input to do whatever they need to do. And then we're using rigid body, the rigid body here on the ball, to add forces. And I'm adding a 3D force, so it's like you pushed that ball in a certain position. And so you can see per the comments, I'm pushing it forward toward the pins and up in the air a little bit, so it kind of arcs towards the pins. Just trying to mimic what would happen on the upswing as you release a real bowling ball in the real world. And then I wanted to play around a little bit with how bowlers spin the ball. So if you're a right-handed bowler, you might spin the ball counterclockwise, and that would slide the ball left a bit. And so that's done with that add force in line 190. And there's a lot of parameters there with an add force to play with, so you can check that out. Then to actually do the spin, I do add torque. So you can see that in 171. And I'm multiplying by the rigid body mass for some of these calculations. And that was an easy way for me to set it so it looked all right once. Then I went in and I was changing the mass of the ball and of the pins quite regularly through the inspector. And if I doubled one, I was always coming back in here and having to tweak the force, because if you increase the mass of the ball from, let's say, 1 to 2 or 3, it's going to require a greater force to give it some motion. So by including the mass in the calculation here, it flows a little bit more easy. So theoretically, I don't need to revisit this script anymore, but I could go into the inspector and change the mass around from 1 to 10 or whatever on both the pins and the ball. And I was trying to get something that looks somewhat realistic, but didn't tweak it a lot. So one of the to-dos that I had listed here at the bottom is to tune the physics for realism. So let's just give it a play and think about that. So you can see I'll go ahead and click the mouse to release the ball. And you see it flies forward toward the pins, and also it'll go left a little bit. So you can see I'm over top of this line, and it's probably going to drift over to this line by the time it gets down to the pin. So let's go ahead. It actually almost got to the center of the wood. You don't get to control that spin in this current setup, but if you wanted to code something like that, perhaps after you click to spin, you then guide your mouse over to the left, and that would give it spin, or you could use the arrow keys to give it spin. Okay. Next, let's take a look at the sound. So I'm going to play the game one more time, and there's two sounds that I'm using. One is the sound of the ball rolling on the wooden floor, and the other is the sound of the pins colliding with any pin hitting another pin, or the ball hitting the pin. I don't have a sound for the pin hitting the floor, and that's only because it sounded like a little bit too much noise for the simple demo, but you could certainly have that happen as well. So I'll show you the coding there, but let's first give it a play. So that rolling sound commences once the ball hits the floor, and then it plays. It's the same duration regardless of the speed of the ball or what happens to the ball later. So listen here and you'll see that the sound of it rolling continues even after it's left the back of the wooden board, which is not realistic, but give it a listen. Yeah, probably about 3 seconds there it was playing as it was falling into the blue background. You could check to see when the ball is no longer in contact with the wooden floor and stop that sound. In fact, I have got something like that commented out there, so you could give that a try. But for my demo, I just wanted to keep it playing. And then you can hear the sound of the pins hitting each other. I got one sound effect for the pins hitting, and it sounded a little too mechanical. And while I don't love the final sound that I've chosen here, it's a little bit better because I changed the pitch randomly, so the sound varies just a little bit, and you will see in the code where that's done as well. So sitting on the bowling ball, there's an audio component. Let's look at that first. So let's see, on the bowling ball, if I give that a click, we have an audio source set up. So audio source is a built-in Unity component. So if I start typing add component, then audio, we get a few different audio related ones. The top 3 are from the Unity engine. So the Unity camera includes the audio listener. So there's one audio listener. And then anywhere you want to play audio, you use audio source, which is what I've used here. We're not using audio reverb zone, but that's a way to add some echo to your sounds. But we don't have that. So the audio listener is on our main camera, and then audio source is on the ball and also on each pin. But first let's talk about what's on the ball. So I've already got the audio source. Then within the project folder, I've got an audio sound effects, and there's 2 files that I found, and you can bring in a variety just by dragging a WAV file or other type of file directly into the project window. And then you drag it into an audio source. So you can see bowling ball rolling is the audio clip set within the audio source. And by default, play on awake happens, which means that as soon as I hit play in the scene, that sound effect's going to play. But we didn't want that. We want to actually call it with code. But once we've got the setup shown here, we're ready to interact with code. So the bowling prefab audio component gets a reference to the audio source, that component we were just looking at. And you can call play on the audio source anytime you want. So what I do simply is on the update, I set have we collided with the floor to false. So every time we restart the scene, we make a flag that we have not collided with the floor. Then Unity has built in for any game object with a rigid body these handlers. So on collision enter, and the comments explain this a bit further. On collision stay, which is during the continuous collision, and then on collision exit, when we stop colliding with the floor. You can read more about the comments, so I'll just want to talk about the first one here. On collision enter. So when the collision between 2 objects first starts. So since this is on the bowling ball, anytime the bowling ball collides with any other object that has a collider, it's going to get called. So the first thing we say is it the wooden floor? If it is the wooden floor and we have not already collided with something, then I say we have now collided with something. So I'm doing this so that we only play the sound once. If the ball bounced a little bit, what I'm doing here is it only is going to start playing the rolling on the first bounce. You probably want to add more sound effects, one for the hitting of the floor, one for the rolling of the floor. It could get more complex to get a realistic sound effect set up here, but this was just a basic setup. Then I had another check in here at one time that if the bowling ball hits a bowling pin, then I stop playing that rolling source. So you can enable that and see how that sounds for you. But as I mentioned before, the rolling sound just plays out. It's about 5 seconds long, and it always plays in the current setup. That's it. Then on each one of the bowling pins, click one of those. So I've selected a bowling pin. Let me zoom in so that's clear. The lead pin, but it doesn't quite matter. And on that, we see all the components related to it, including an audio source. But this time I have bowling pin hit sound, second sound effect from the project. And I also have play on awake turned off. So now we're ready to code something for the audio there. So you can see that the only custom component that I've got here is this one. So I'll open that one up, and it's bowling pin prefab audio component. Really doing something similar. I'm just getting a reference to its audio source. Then I get a random number, so I want to pitch bend, turn it a little bit higher, a little bit lower. So instead of bop, 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 it sounds like bop, bop, and bop. It changes the pitch a little bit for variety in the sound effect. Then we have the same handlers here. Enter, stay, exit. And on enter, I ask if what we're colliding with is either another bowling pin or the bowling ball. Then I hit play. If I didn't do this check, then we would also hear a sound play when you hit the floor, which, as I mentioned, was just my personal choice, was to not have it make a sound when you hit the floor. But you could certainly uncheck, stop checking for 113, 114, and just play in the case of any collision. And you could use the stay and the exit if you wanted to as well. All right, let's see where we're at. So we've talked about GUI text, sound, and mouse key input. Let's talk a little bit about what these blue things in the hierarchy are. So I've got an empty game object called bowling pin prefabs with an S, and if I select that, you can see it's got the resize handlers right there. That's an empty game object, and I just dragged in all of the pins. The blue text in the hierarchy indicates that it is a prefab, and a prefab is a special type of game object inside Unity. Whereas the invisible mouse detection cube is not blue, so it is not a prefab. The bowling floor itself is not a prefab. The instructions test is not, because these are all with black text. And if we expand a few of these other game objects I'm using as folders, we can see the majority of the variety of game objects I have are all black text. The only ones that I've chosen to make a prefab out of are the bowling pin and the bowling ball. Now, in general, the decision to make something in prefab is as follows. If you have one instance of a scene, one instance of some object in your scene or in your whole game, then you don't really need to make a prefab. A prefab is once you want to use the same object more than one time. So the bowling ball didn't really need to make a prefab out of it, but the bowling pins, we want to make a prefab, and here's why. Because if I make an adjustment on one pin, once I lay the 9 out there, so let's say I've got one selected, if I was to tweak any property on any component here, then have to manually go and update that same change on all 9 pins, that would be quite a pain. And that's the default behavior you'd need to do, because you'd be dealing with 10 copies of the pins. And the changes you make in the inspector on a copy don't propagate to the rest of the list. But if you select any game object and go to Assets, Create Prefab, it will take what you have selected and it will make it a instanceable object. And it also puts it in this little icon here in my list of prefabs. A second way that you can do the same thing, let's say I wanted to make a prefab out of instructions 3D text, you take anything at all from the hierarchy and just drag it anywhere into your project window. And that little shortcut black arrow with white outline that you see is doing the exact same thing as that create prefab option. So I don't need to do it there, but then the only change that you'll see again is it turns blue over in the hierarchy view, and then up in the top of the inspector you'll see prefab now as a new menu, and that menu gives you the ability to select all the prefabs, or sorry, select the original prefab from the library. It allows you to revert any changes that on this particular instance maybe I've done a mistake and I want it to go back to the way that all the prefabs are. Or if I was to make a change anywhere in any of these properties, and then I want to click apply, that's going to have that change propagate to all the pins. So you are able to put prefabs inside prefabs, but there's challenges to that, and you can read a lot about that online if you just search for Unity prefab in prefab or Unity nested prefabs. There's some challenges there. It doesn't work as well as I would hope. But for just doing some game objects with scripts and putting one prefab the way that we've done it here, it works great. And I'm able to go in and apply and make the changes that way. Prefab is a whole issue unto itself, but it's very useful, and you're going to want to use it in any project where you want to repeat objects and still be able to kind of edit one and propagate the change across all. That's that. Then, where are we here on our list? Let's talk about that second camera. So something that was a surprise to me is that in Unity, in order to do this picture-in-picture little second camera window in the upper right, you simply go create and camera and add a second camera, a third camera, a fifth camera, as many of them as you want. And what's weird is, let me go ahead and add a new camera here. Let's say I add camera and I call this third camera. And you can see here in the scene view, I'm now manipulating where it is, and great. So we've got a third camera, but the problem we see immediately is that that game view is only showing our new camera. So what you need to realize, and what I didn't realize for a bit when I was doing some research on a project, was that it's actually rendering camera 1, then camera 2, then this new camera 3, all on top of each other. So by going into the camera inspector, I can adjust these properties in the normalized viewport rec. And by sliding around the X position, you see, oh, I'm revealing the other camera. By changing the W value and the H value and the Y value, I can manipulate that to occupy the real estate on the screen that I want. So here we have 3. And programmatically, you could edit those values if you wanted to change this on the fly. You could also programmatically turn cameras off and on. But that's how I set up that camera in the upper right. I just floated a camera over the pins, got it looking down the way I wanted, and then tweak those normalized viewport rect properties. So I'll delete that camera, and that's it. That, you can see, it's super nice. You don't have to code a second view into the scene. You don't have to do that with GUI only. That's a true 3D camera that I have locked to a 2D looking view, but it's really nice. I'm able to add the detail into the user's experience. They're able to see which numbered pin they hit in this case, or in your game, maybe a map. Right. One other thing that is important with, let me say 2 things. So let's look at that second camera. So now I'm looking at the properties for the camera in the upper right. There is 2 things that I think are key. One is the clear flags will indicate how that second camera overlaps the first. So you may want a box around the camera. I didn't. I just wanted to see the wood and then immediately the blue background in the scene. So it's really a box of just GUI. But you can choose kind of what is the background of that camera. And I have the background turned off, given depth only. Another one is the culling mask. I can choose what in this world is rendered. So if I add back the GUI layer, you can see that the bowling and the score UI GUI text in the upper left of the main camera is also showing in kind of a weird, awkward way on top of that second camera. So I don't actually want the small window to render that GUI stuff again. So what I did was I went to the score Gui Text. I gave it a layer of GUI layer, which wasn't there by default. I had to use add layer. And then once I've done that, when I come back into the second camera, inside culling mask, I can choose what is culled or not rendered in the scene. So I can choose GUI layer. Let's say I didn't want to show the floor. I could change mixed down, go to wood floor. So I'd turn off the rendering of the floor. That might even be more cool. Let's take a look at that. Right, so you can choose what you want to render, and while both cameras are looking at the exact same world, you can selectively say one renders everything and one renders most of everything but not the GUI, and in this case not the floor. So you got a lot of freedom to do what you want there. That's really great. So I'll turn the wood floor back on. That's it. So we've taken a look at everything here. We've got the GUI text, the sound, the mouse key input, prefab, second camera. These are all more advanced Unity engine, built-in specific things. So while this video series is concentrating a lot on C# here, we wanted to take a look at more of the Unity engine specific classes. As a last moment, let me just explain the to-do. So, if you want to jump in and get this source code, you can see some suggested activities here. So maybe you want to create a standalone empty game object and put some component logic on there. That's often called a game manager class. You can check around on Google, or in a future video I'm going to cover how to create a simple game manager. And a game manager, in this case, to give a specific explanation, I have the logic that puts the score, 0 of pins knocked down, or 0 of 10, or 10 of 10. I have that logic on the ball, but maybe it doesn't make sense for the ball to really dictate the GUI. There's a disconnect there, just in an architectural standpoint. So you make a standalone manager class, and it handles maybe the GUI and the game score, and if you're allowing them to play a full game of bowling, maybe it keeps track of the round they're in, or the frames it's called. So that's one thing. You could choose different sounds. Sounds I've got aren't great. You could even put some more sound effects in, like the ball hitting the floor. I only have the ball rolling on the floor. Also, as the pins fall off the back of the wood there, they fall forever off into the blue. And you may want to optimize that. And I've got a couple comments, I think, in the source code about how you might want to do that. But you could either destroy them, or you could, you basically destroy them. But you could either do it, 5 seconds after they leap off the wood, or you could do it when they reach a certain Y coordinate, or if they hit an invisible floor that's maybe lower than the wooden floor. There's a lot of ways you can handle that, but for right now it's not optimized. Then here I'm just throwing the ball once, resetting all the pins. In real bowling, you actually get 2 attempts at the same configuration of pins. So if I hit 3 down and then I hit 7 down, then in those 2 frames I've gotten all of the pins down. So you could add in step 4 and 5 there a little bit more of the rules of actual bowling. Then you could prevent the ball from starting in the floor. I've pretty much corrected that just by using that invisible space that I mentioned. But actually, if I use the arrow keys, yeah, it does let me go into the floor. So you could put some logic that every frame, while we're in aim mode, it just makes sure we're above the floor. So that's another option. And then tuning the physics. So maybe you want to make, right now the pins seem really light. Maybe you want to have the pins have a little bit more mass. Also, you can see when I drop from here, the ball bounces. Maybe you don't think that's realistic. And the way that you change those values is you'd select one of the physics objects, go to the rigid body, and mass, a higher number, makes it seem like a more heavy item in reality. Drag creates more friction. And then we have what are called physics materials, one applied to the wooden floor and one applied to the bowling ball already. And so you can tweak some additional values, particularly the bounciness there. All right, that's it. Thanks.